So, welcome to the 1015 podcast, and today we're going to talk about why take this class. What's good about Python with machine learning? Well, we're going to talk a little bit about what's good about Python, and then we're going to talk a little bit about what's good about machine learning. But first, let's talk about Python. If I go out to Monster or one of those job sites, regularly what I'll see is that the top or one of the top two requirements for getting a job in IT is programming in Python. And how did this come to be? Python is a language designed to be easy to learn. And because it's easy to learn, there are a lot of people that want to use it. It's an easy to read, easy to learn language. It doesn't have the best performance. It's not a universal language for all things, but it does have a lot of features that make it really useful. And, we can look at a lot of different kinds of jobs, but my last analysis on Monster, where they'll actually say how much they're willing to pay for this, is that the top paying IT jobs out there, not only is it one of the most common, but with that site and a bunch of other sites added together, is that the average is $124,000 a year for programming in Python. And that's more money than you're going to make doing other things like programming in Java. Java has been in decline for years, and Python is still growing. There are a lot of websites that use Python. Perhaps at some point you've used YouTube, maybe in this class. It's developed in Python using a package called Django. The visualization tool that we are using in the class is developed in Python using a web framework called Bottle. So there are websites, a lot of them. Instagram is a Python program. The installation and setup tools in our Visual Studio Code are written in Python. So you're using Python, and it's used for a lot of different things. It's really good for taking libraries written in C and building them into a usable user interface, where instead of having to know all the intricacies of C programming, it exposes this complex library to people to use it for other things. So most of the data analytics, most of the analysis done in something like political science, which is my son's major, is done in Python using analytics libraries that are written in C, but are really hard to use in C, but relatively easy in Python. So we see it used as not just a language by itself, but also for these kinds of other analytics things. NumPy is an example of one of those. It's a mathematics library that, underlying the covers, it's not written in Python, but the best interface to this is done in Python. And it's one of the most important scientific analysis libraries. Now, later in the semester, we're going to use a thing called Tensorflow. And this is where we bridge the gap to machine learning. TensorFlow is a package that Google developed for doing a variety of different machine learning and analysis things. For instance, the image search at Google is running behind the covers in TensorFlow. And Google's parent company, Alphabet, has another company called Waymo that does self-driving cars. The way that the self-driving cars recognize things to do the driving is done with Python and TensorFlow. So there are a lot of these things. In fact, if you go to a travel site like Kayak, they have 56 in-production machine learning systems that they use for their website. Every single one of those is written in Python using TensorFlow. That is their set of tools that they use internally. So lots of applications are written. And what makes it so special? Because TensorFlow is written, again, in C code, and it is available in other languages. There are, if you use Google's mobile apps, they're using TensorFlow Mobile, you're using JavaScript, but most of the server-side stuff, and the easiest way to go about implementing that server-side stuff, is in Python. We'll get to understanding what a tensor is, but Basically, what it does is it allows you to take a set of input data, and by mid-semester, yes, you're going to appreciate this more. It's hard to write programs, but it allows you to take that input data and write a certain kind of program without a programmer, as in the computer learns how to program itself for a problem that you have no idea how to tackle. But given enough examples of the right result, it can figure it out. And that's what TensorFlow does at a certain high level. Now, that's kind of the bridge for us to talk about machine learning. Now, machine learning spans a lot of other things besides just TensorFlow. And I used machine learning 20 years ago in managing databases, but the piece of machine learning that we used was taking estimates of the rate of change in storage and estimates of CPU and doing forecasting and learning what the likely outcomes of different events were and how they would forecast the usage of storage for a database. And that wasn't using TensorFlow, but it was a kind of machine learning. It had far more to do with statistics and averages and doing forecasting, but we did do machine learning. So there are other kinds of machine learning. But these days, most of the time when people talk about machine learning, what they're really talking about is things that involve convolutional neural networks and generative neural networks. And TensorFlow, that's the realm that it works really well in. And you can use TensorFlow for other mathematical things. It has those capabilities too. But its learning and its capabilities in the land of these neural networks is what makes it important. And Python makes it convenient to use. And in the first half of the semester, we're going to learn how to build, fancy subroutines and objects and use list comprehensions and lots of good things about Python. And then in the second half, we're going to use TensorFlow, and we're not going to look at any of that stuff. We're going to write programs that just kind of read down straight in a line, and they do, okay, read in this set of stuff. Okay, now that you got this set of stuff, transform it in these kind of ways, manipulate it, and then run it into this piece of software called TensorFlow. Okay, here's the result. And you go, wow, we learned all that Python, and then we only use a little bit of it. But the fact that Python can adapt to this huge library, TensorFlow is a big piece of software, and make it easy to use speaks highly of the qualities that we want to get out of Python. Because it can do that, it can also build websites like YouTube. So that's kind of the core of what's up with that. But why do we want to mess with machine learning? I mean, okay, self-driving cars. Self-driving cars are probably going to be the first actual robots that people have in their lives. And they have their challenges. I was reading an article recently about a Google engineer that's actually using in Phoenix their self-driving cars. And he was on his way to work and he hadn't had breakfast. And he said, and this is last year, he told the car, go through Taco Bell's drive-thru, because he wanted to get some breakfast. And he's blind, okay? So, the car pulls up, turns, goes through the drive-thru, goes through where you're supposed to pick up the food, gets back on the road, and continues driving. The concept of go through the drive-thru, it got the concept, but it missed the concept. As in, yes, it never stopped and allowed him to order food, and there was nobody else in the drive-thru. It literally just did what he said. It went through the drive-thru. So, of course, he's one of the beta testers for this, and he gets a hold of the team that does the self-driving cars, and he said, well, it did this. And there's a meaning to go through the drive-thru that you don't got. So you got to laugh about that. Yeah, it's kind of funny, but at the same time, that's the way computers are. They're very literal. If they're set up to do a certain thing, they follow their instructions. And that kind of behavior is not going to go away, but as we get better and better at understanding a myriad of things, TensorFlow used to analyze what he's saying and what the meaning is behind the speech recognition. TensorFlow used for navigating the car down the road. TensorFlow used in this myriad of different ways for figuring out the route that you take to get from one point to another point. So it's used in a bunch of different ways, even in a single application like self-driving. And you go, all right, we've built these robots and they're useful and they can drive us around, and this is a nice thing. Well done, they're safer than human beings driving. Before your age of 34, your most likely cause of death, and this is even with the pandemic we're having, the most likely cause of death you have is an automobile accident. So Waymo has driven 26 million miles in the greater Phoenix area with 0 fatalities. That is way, way less than human beings if they'd driven the same amount. And they have had 3 accidents. None of them were their fault, and all of them were fender benders. They weren't anything that injured anybody. So 0 injuries, 0 fatalities in 26 million miles. That is a huge deal. Now you go, okay, how big of an impact is it going to have? Well, in most states in the United States, self-driving cars, the number one job that you can have out there, and there are 5.1 million people employed in the United States doing it, is being a truck driver. Truck driving will just disappear with self-driving trucks. Yeah, it's a really hard problem to solve, and they've been working at it for years, but that entire industry suddenly will be automated. And I actually think that that's going to happen for several economic reasons much faster than you're going to get, as individuals self-driving cars. The reason for it is that truck drivers are legally required to drive 11 hours or less per day so that they're not falling asleep at the wheel. And that means that most trucks sit idle at least half of each day. Now, as a business owner, having a piece of capital equipment sit idle half the time means I can double the productivity of my fleet if I can just get rid of the driver. And it's not that the drivers are doing a bad job. It's just that my capital costs just got cut in half. And that is a huge deal. In trucking companies, 22% of their expenses is their capital costs. If you can cut that in half, that will change that industry. Now, I did mention 26 million miles, no accidents. Now, the second field that's going to be impacted tremendously is when we get self-driving cars and they commonly occur, we're going to cut down on traffic fatalities. And that's a good thing. I mean, 250,000 people a year die in the world due to traffic fatalities. It is a big deal, and lots of people are injured. In fact, if you look into hospital records, you'll find that 1/3 of all healthcare in the United States is consumed in dealing with traffic accidents. So if you eliminate most traffic accidents, you don't need those people. You don't have that suffering. You don't have those physical therapists. You don't have those bone and joint doctors reattaching limbs. I mean, it is that gruesome, but that is what you get rid of. And you don't have all these people that are maimed for life because of a traffic accident. You don't have all these people dead from traffic accidents. So that is a big deal, and that's probably the largest thing that we can do to improve health in the world right now. And it is a bigger deal than overcoming the pandemic that we're in right now, because more people are going to die from that than the pandemic. So at least that's what the numbers are up to age 34, if you look at the risks in life. So that is a huge deal. Now, that's a big economic impact. How about other things that they use convolutional neural networks for? Like, there's a researcher that I know at MIT. She had breast cancer, and she went in and got diagnosed. A radiologist looked at her breast cancer and identified it, and she got treated, and she's in remission. But in the process, she realized that, yes, this is a bunch of images, and something like TensorFlow is really good at classifying images, and she's a computer science professor. So now she's doing the research work and has developed a system that does classifications of images for breast cancer and is doing a better job than radiologists by a significant margin. And that is in the works. There are a whole bunch of things like that where we can take this thing that has traditionally been a complex, difficult, high-training, white-collar job, but we can improve it with a tool that classifies images. Another example of that, and this is one that I have actually done some consulting work with the people at the factory that this is involved in, is some years ago I was working on a contract with a guy that had worked his way through college being working in a factory, classifying cucumbers. Basically, he picked out the little pickles from the big pickles. He was a Vlasic dill pickle picker. Yes, those really exist. And one of those things that Vlasic wanted to do is, you got to understand something. This is one of those mind-numbing low-pay jobs. As in, they would put people out there on the line to do pickle picking and separate the baby pickles from the big pickles from the really big pickles to classify the pickles to go into the bottles. And if the person could take the work, they'd do it. And there would literally be people that would start working at this, and it would be so mind-numbing after a while that they just fall over. And it's that bad. So Vlasic wanted to replace this horrible job that just fries people's brains with TensorFlow and a system that would classify the pickles. And this is actually a really simple classification problem. I mean, it's basically, is the pickle straight, is the pickle curved, and what size is the pickle? And yes, they use some fairly simple stuff to classify pickles and replace the pickle pickers with, yes, a machine. So that's industrial automation, and those people aren't around, but what a job. Can you imagine 8 hours a day staring at pickles going by and going flick, 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 flick. What a job, man. That is just a horrible, horrible job. So there are all of these jobs that you can replace with machine learning. And machine learning is not the only thing that's going on in the computer field right now. There's also some other things that are going to have a big impact. But the Bureau of Labor Statistics has done a bunch of research, and other people, on what jobs are most likely to be automated by machine learning. And computer science is one of the ones that is least likely to be automated, although there are some pieces of it that will be automated, like being a database administrator and managing storage for a database can be automated. I know. I built the software. I sold the company that did it 20 years ago, and people are still working on that kind of stuff. But it can be automated. It is possible. But there are a lot of things in computer science that can't. But how about the surgical sterilization people that take trays of tools that come back from surgery and sort them by hand and clean them? And basically that sorting costs somewhere around 60 cents per tool per use. And all it is image classification. And that field costs the economy $18 billion, over half of it, and that's just in the United States, $18 billion in labor. Over half of it is this sorting problem. That if you build an image classification system, it can replace it. So there are this huge field of classification problems that can be done. And when you start looking at it, over the next probably 20 years, TensorFlow, machine learning, other machine learning systems, not just TensorFlow, but others will be developed and used, should grow to be somewhere between 20 and 30% of the world economy. Now, right now, all of the computer field, the entire computer field is 3%. So going from 3% to 30% of the world economy means a tremendous amount of growth and a tremendous demand for people that understand how to build these systems and how to get rid of some of these mind-numbing jobs. Yes, truck driving is a mind-numbing job too, because after a while, the most likely way for a truck driver to die is to fall asleep at the wheel and drive off the road or hit someone. So there are a lot of those. There are a few of the white-collar jobs that, can be automated and gotten rid of. But mostly it's these really dull, mindless jobs that people suffer through for low pay, and these things can be replaced and implemented. And it takes a lot of time, and suddenly you've gone from, a low-paying job to a few high-paying technical jobs that are probably a lot better. But that transformation of the economy is the Industrial Revolution that we're looking at right now. And it is going to be as big a deal as the Industrial Revolution at the turn of from the 1900s to the 1950s. So that is a huge, I can't understate how big, I can't overstate how big a change this is going to be to the economy. But it is happening, and that's the reason for this class, is a lot of this machine learning, it requires some programming, but it is not so complex that we can't get a good handle on how it works and why it works using a nice language, and use it as a tool to help us learn Python along the way. So I'm involved in a number of these different kinds of projects. I've used machine learning for things in the past. I've built a business that uses machine learning. And these kind of things are going to become an increasingly common piece of all sorts of fields. And lots of money is going to be spent on it, and there's going to be lots of jobs. And they tend to be really high-paying computer jobs. So that's the reason for Python with machine learning, is it's the future of all sorts of industries. And it takes people that understand how to do some programming. All right, with that,